Hey folks, Morgan here. It's been a while since we've been able to do a lab, and I feel bad about that. That's really the best part of taking a chemistry class. So we're going to recreate one here and give you the data so that you can write it up and give you a couple ideas just in case you want to try to do it on your own at home. So my wife very kindly offered the use of her laboratory today. And when I was at school last week to turn in my keys and clean up my room, I picked up this, and this is the forensics kit that we use for Science Olympiad. And it actually has quite a bit of laboratory equipment in it. I figured we might try to film a couple labs before the end of the year, and this would be helpful. And out of it, I'm going to take this, which is a standard laboratory thermometer. You've seen these, you've used these, they're from Flynn Scientific. Some of them that we have a red cover on them, okay? But it's the same idea. Now, I have a few other thermometers to show you over here. This you might have at home. This is a meat thermometer. And the meat thermometer that I have can read in either Fahrenheit or in Celsius. And I've set it to Celsius to be consistent. It doesn't give me a tenth of a decimal place, it just gives me round numbers. But it will work pretty well for the experiment that we're doing today. So if you have one of these or a candy thermometer type, you can actually do that. Use it. I also have this, and this is a really neat device. This is an infrared laser thermometer. And it's going to be really good for us when we start out to get the temperature of the solid water, the ice cubes as you might call them. But it doesn't necessarily work real well for water in the liquid phase, okay? Some of you might have these, especially if your parents work in certain industries. They're very common, okay? Now, what else do we need? I've got a beaker from the forensics kit, although don't try and use glassware if you do this at home. Do it in a metal pan. I've got our version of the Bunsen burner, the stove, and I've got some ice cubes. So what I'm going to do, if you give me a second, it's kind of my Mr. Rogers moment. I want to get out of this blazer and put on some more appropriate laboratory wear. Don't want to mess up some nice clothing. Okay. Now remember those 6 words that we start every lab off with: goggles, hair, shoes, pants, stools, and shelves. Well, there's no stool for me to stand on. Okay, I don't have to worry about that. I've got my goggles. I don't have to worry about tying up any hair. It's all been torn out from working with teenagers for so many years. Okay, I got my long pants and shoes on, so I'm good for that. So what I'm going to start off with is actually taking some data. So we're going to come and zoom in over here and see what we got going. This is a kitchen scale, and most kitchens have them, okay? I have set this one specifically to measure in grams like we do in the lab. And I'm going to take this beaker, and I'm going to put the beaker onto the kitchen scale. It'll serve as our balance. That is 166 grams. So the mass of my beaker will be recorded as 166 grams. Don't ever forget to write your unit with your numbers. Now, I'm going to need to add some ice. So I've got a supply of ice over here, okay, in an insulated cup. And I'm going to take some and just dump it into there, okay? Now, put this back onto the balance, and this time it is 298 grams. So I will be able to actually take the difference between those numbers and know the mass of water that I started with. And one of the points of this lab is understanding whether or not the mass matters. And it doesn't, not in this experiment. With a whole group of people doing it, you typically compare data, and mass is just not going to be relevant. So I want to know about the temperature of this ice before we start. So I'm going to take this laser thermometer. I'm going to point it, squeeze the trigger, and you can hopefully see that red dot that's in there. Okay. and I'm getting about negative 3.2 degrees off of that. Okay, when I point this into the freezer itself, what I end up getting is about negative 20 degrees Celsius. So the data that I'm actually going to give to you folks for doing your lab write-up, the temperatures will start in the freezer itself. Okay, so the point is to monitor the temperature of this every 15 seconds while it's heating. So the beginning of it says to take the temperature every 15 seconds for 2 minutes before it goes on to the heat. And I do that either with a laser thermometer or by holding this thermometer on. And this is not quite as accurate because the thermometer's not submerged, okay? So I'm not getting a good reading. It's picking up the temperature of the air quite a bit. So going here, doing this style, I will have recorded the temperature of it every 15 seconds for a couple minutes. Then this is going to go on to my heat source. This is a very big Bunsen burner with 4 actual burners operating. And what I'm going to do is turn it on, set it to low. Now, I chose the burner in the back on this stove because this stove has 2 different sized burners. These here are, about yay big, and this one back there is about this big. And I went with the smaller one because the beaker itself fits on that burner very nicely, okay? And what I'll be doing is monitoring the temperature like this, and we'll write it down every 15 seconds for as long as I need to. I can't tell you how long it's going to take for this to come to a boil. So what I will do is take my phone here, just like you do. I'll start the stopwatch, and I'll just look at it, and every time it hits 15, take the temperature, and my wife, who is helping me out today, will have her phone also, and she will put the temperature directly into a spreadsheet on her phone, or you can do it into a laptop, either way, just like we do at class. So this is what our setup's going to look like. Remember, never freestand the thermometer. That's not good, okay? That would be taking the temperature of the glass rather than taking the temperature of the water. And I've already got some liquid water down there, as you can see, and we'll be writing down these temperatures every 15 seconds for as long as it takes, and then we're going to let it come to a boil. When it comes to a boil, we're going to continue to take the temperature every 15 seconds for at least 2 minutes. Now, I don't want to bore you with literally staring at water waiting for it to boil, because a watched pot never boils. So we're going to stop the video, and then we will come back with a second video that actually shows what's happening when it goes to boiling. Hey folks, welcome back. We have been watching this for a while now, and the temperature is going up. You'll notice we're right now hovering at just about 100.2, 100.3. Occasionally my hand slips a little bit and I touch the glass and it goes up. I pull it back and get a more accurate reading. And what I'm hoping that you're noticing is that to a couple of significant figures, the temperature staying constant. We're basically right there at 100 degrees. Not any higher, not any lower. And as this water undergoes its phase change, the temperature staying constant. And I'm going to run through about 2 full minutes of this water boiling and taking the temperature every 15 seconds and show you that we're going to stay pretty much at a constant temperature while it does that. Now, again, if you're going to try this at home, make sure you use a metal pot. Make sure you use nice gloves to protect yourself from burns, okay? Goggles are always a must, okay? And I'm sure you can find that stuff around your kitchen. Okay, well, thanks for tuning in. You'll find the data for this lab on the web page, and you'll be able to create your formal lab report and graph based on that, and we'll post a due date for that in Schoology. Okay, thanks for tuning in. A big thank you to my wife for letting me invade her laboratory. She tells me I need to finish up this video now because she wants to start using the lab. And we will do another lab like this at the end of next week. Have a good day, stay safe. This is Morgan signing off from Redondo Beach.